Marianne, you can move, sit where you feel comfortable. So first, let me introduce Catherine Wolfram, who is in the light, is it blue, green sweater, and she has is the faculty director of the Energy Institute at Haas at UC Berkeley, and also the E2E project, a research organization focused on energy efficiency. That's a collaboration with University of Chicago, MIT, and UC Berkeley. She studied the electricity industry around the world and has analyzed the effects of environmental regulation, including climate change mitigation policies on the energy sector. We also have Marianne Piet sitting in the gray, with the gray jacket closest to us. She's a staff scientist and director of the Building Technology and Urban Systems Division at Lawrence Berkeley National Lab. She oversees Lawrence Berkeley's building energy research activities for the U.S. Department of Energy and other R&D sponsors. She's also director of the Demand Response Research Center that evaluates and develops new technology to improve the capability of demand-responsive and end-use loads. And then finally, furthest from us, also in a dark gray jacket with a black shirt, is Professor Michael Simonovich, who is the director of the California Lighting Technology Center and associate director of the Energy Efficiency Center at UC Davis. He established the Lighting Technology Center, whose projects accelerate the development and commercialization of energy-efficient lighting technologies for both residential and commercial applications. This panel will be discussing current energy efficiency practices along with any challenges and successes. I'm intrigued to hear about the current modeling of heating, ventilation, and air conditioning systems, and to learn about savings due to lighting advances in building and residential homes. Do we have more room for improvement? How can California maximize its potential in lighting efficiency? First, we'll hear from Professor Catherine Wolfram. Welcome, Catherine.
Great. Is this on? Can you hear me?
I think so.
Okay, great. Thank you, Assemblymember Quirk, and thanks to the rest of the members of the committee. As Bill said, or as Assemblymember Quirk said, I'm Professor Catherine Wolfram. I'm the Cora Jane Flood Professor of Business Administration at the Haas School of Business. I'm also the Faculty Director of the Energy Institute at Haas and a Faculty Director of the E2E project, which is a joint research initiative between UC Berkeley, MIT, and the University of Chicago. I've been doing research on energy markets for over 20 years, and one of the main areas of focus for me has been energy efficiency. I made this choice to focus on energy efficiency because every major carbon mitigation strategy out there relies heavily on energy efficiency to meet its goals. So my colleagues and I want to make sure that A, we're actually getting what we think we're getting, and that we're saving the energy that we think we are from energy efficiency programs, and B, that we're doing everything possible to select the best energy efficiency programs, even if that means ending underperforming programs. So I'm going to preview my remarks by saying that we have room to improve on several fronts, and it's crucial that we do this. We can't keep our heads in the sand and pretend that we're addressing climate change if, in fact, we're actually not. So let me start by noting that energy efficiency is hard to measure. There's not a meter that runs backwards to count kilowatt hours not produced because of an energy efficiency program. What you need to do is establish a baseline or counterfactual which describes what would have happened absent an energy efficiency program. For example, you want to know how much energy a household would save if it, for example, you want to know how much energy would a household have consumed absent a home energy retrofit. So you need to understand that counterfactual. But this is difficult because it involves modeling human behavior and human decisions that would have been made in the state of the world that you don't observe. For example, you would need to know if the family that got a home retrofit would have turned down their air conditioning afterwards, absent the program, or whether they turned down their air conditioning because the retrofit made it cheaper to keep the house cool. You would want to know whether they changed anything else in the house, like whether they would have acquired new electronics absent the program. And this is not an easy task. Unfortunately, for 81% of the energy efficiency programs in the U.S., the evaluators have basically taken a pass on this difficult task, and they're using ex-ante engineering estimates to measure the savings from the programs. So they don't even go look at what happens at the house after a retrofit, but they rely on estimates that are made before the fact. One problem with engineering estimates is that they're not very good at modeling human behavior and decisions that people are making. There are viable alternatives. As the previous speaker mentioned, they're being worked into the EM&V guidelines that are under the Clean Power Plan, and my colleagues and I at the EDE project are dedicated to finding more opportunities to use randomized control trials and related quasi-experimental approaches to measure savings from energy efficiency programs using ex-post real data. Let me say that randomized control trials are used widely in medical, social science, and business applications. The FDA will only accept evidence from an RCT before it approves a drug. Companies like Google rely on randomized control trials all the time to answer questions about their business models. They call them A/B tests. And there are also several important cases, for example, from the medical literature, where results from previous work that didn't use randomized control trials was overturned when a randomized control trial was run. So this points out that it's really hard and sometimes misleading to learn from what are called observational studies, to learn from anything that doesn't involve randomization. So my colleagues and I were able to conduct a randomized controlled trial to measure the energy savings from the Weatherization Assistance Program in Michigan. The Weatherization Assistance Program is a federal program that provides energy efficiency retrofits to qualified low-income homes at no out-of-pocket cost to the household. I've summarized some of the findings from our work on the handout. So first of all, given that the Weatherization Assistance Program is a public program, we used a variant on a randomized control trial because we couldn't basically force a treatment group to weatherize their home and prevent a control group from weatherizing their home. So what we did is we encouraged a random set of households to enroll in the program. And one of the benefits of this approach is that it helps us learn about how to get people involved in the program and what take-up is in the program. So the first finding is summarized on page 2 of the handout. And basically, this makes the point that we found that it was very hard, in fact, much more difficult than we would have expected, to encourage people to have free home energy retrofits done at their homes. So in our treatment group, we had nearly 9,000 people, and we made a personal contact with 2/3 of them. Somebody knocked on their door. Somebody explained to them that the program would be free, would involve no out-of-pocket costs, and that we would help them go through the application process. And still, the second red bar on the graph there shows that we got fewer.
Perhaps you could give the numbers.
Oh, sure.
Since most people don't have the handout.
Yeah, so as I said, we personally contacted about 2/3 of the people.
About 6,000.
Yep.
About 6,000.
Yep.
Okay.
And then we only got 15% of the 9,000 to enroll in the program. My math is not that fast.
So a little over 10,000.
A little over 1,000.
Oh, excuse me, 1,000.
Yeah.
Right.
To actually fill out an application. But these people, the majority of them knew that the program was free and that we would help them with the application process. So one thing this could suggest is that though the out-of-pocket costs are zero, there are other perceived costs of participating in the program. For instance, an unknown contractor hired by the government will come to your house, muck around your house, drill holes in your wall, and who knows what else. Slide 3 summarizes the energy savings.
So what number actually applied, and then what number actually weatherized?
Yeah, so we got about 15% that applied, so a little over 1,000, and then actually weatherized was lower than that, was about half of that. We got about 500 people who are actually weatherized by
So
the program.
500 out of
9,000.
Out of 9,000. Okay.
And why the drop off? If they made the application, isn't that all that they have to do?
So that's a good question. There are a variety of explanations. In some cases, they made the application, but then they didn't stay at home to meet the auditor. In some cases, they made the application, but they didn't actually qualify from an income, so the agency looked in. In some cases, the program ran out of money and didn't, their application was fine, but they were put into a waiting list.
So really, we can't really learn much from the drop off between applied and weatherized, but we can learn a lot from the contacted to applied.
I think that's fair to say. Okay. I think that's fair to say. I mean, not all of the applied would have gotten weatherized, even if it was 100% funded, but I think that's fair.
And what are some of the possible other explanations? I mean, in general, energy is one of these things that people do not respond to it with rational price signals in the same way that they respond to other things. So you kind of wonder from an economic viewpoint, is that because it's so heavily subsidized that people are not acting rationally because it's so cheap? Or what is it, right?
Yeah, so I'm not sure I know. I can speculate. This is a low-income population, and they have a lot of things going on, telling you that you have to wait at home, take a day off from work, and as I said, somebody of unknown quality who you don't know is going to be mucking around your attic. I think there are perceived costs to that. There's also just people have a lot of other things to think about, and saying that you'll save money over the next 15 years is not as important as being able to, apply for a job tomorrow.
Well, so if I was a liberal, I would say the answer would be then to pay them to stay at home for that half a day.
Okay.
And if I was a conservative, I would say, no, let's charge them 10 or $20, a nominal amount, so they have a stake in it. Do either one of those things work?
Let me get to the second set of findings before you pay them to stay at home. Okay. Okay, so in terms of energy savings, we found disappointing results. We found that the program did save households 10 to 20% on their gas and electricity bills, but this was considerably less than the ex-ante engineering estimates suggested. And so that should make us worried if we're using engineering estimates as to specify how much energy we're saving from these energy efficiency programs. So as you can see on page 3, the program saved less than 40% of what it was supposed to do. That's the 39% wedge there. As a result, the government was spending around $5,000 per cost, and this is direct costs, so it doesn't include any of the administrative costs. It does not include the cost that we incurred encouraging people to sign up for the program, and generated about $2,500 in savings. So it's just not a good return on investment. It's a negative return on investment. So I think that answers your question about whether you want to pay people to stay home, because the energy savings that you're generating are not justified by the cost that you invested. So we also looked for evidence of what's called the rebound effect. And this is the idea that I referred to earlier, that people will adjust their indoor temperature after a retrofit. And we found no evidence of this. Page 4 presents results from visits we made to both treated and control households, where we measured the indoor temperature and looked at their thermostats. And both weatherized and control households kept their homes at almost the exact same temperature. So this particular explanation for why the engineering estimates might be so far off does not turn out to be true in this case. I think that our study points to the need to get better engineering estimates and to do more ex post analysis. We need to figure out why the engineering estimates are so far off and if there's a way to make them better. And we need to develop a continuous feedback loop where we evaluate using ex post data, we refine the program, evaluate it again, and make continuous improvements. Or we need to get rid of programs that seem too hard where it seems too hard to improve the results. I will point out that our study is not the only one to find this kind of result on engineering estimates. There's an emerging body of evidence that suggests that engineering models are significantly overstating energy savings from energy efficiency programs. I'd be happy to provide more examples. Relevant to home energy retrofits, there's a CPUC study that Assemblymember Quirk referred to that found that the retrofits from the Energy Upgrade California program save significantly less than was forecast by engineering estimates. We do need to do better, and I'd like to strongly encourage you to do three things. First of all, I think we need to encourage the use of scientifically rigorous methods which use ex post actual data to evaluate energy efficiency programs. Second, and more generally, I think we need to insist that evaluators follow scientific principles, including transparency and independence. Too often, the evaluators are hired by interested parties, for instance, the utilities, and they want to show that a program is succeeding. I've reviewed a number of studies submitted through the CPUC process, and the quality of the analysis is quite low. And third, I think we need to be ready to discontinue programs that aren't successful. Now, I realize that it's not particularly uplifting to hear this. I wish I had a more hopeful message. I wish I could show you that the program exceeded our wildest estimate. And I think there are energy efficiency programs out there that are like that. We're currently implementing a study of an industrial energy management system software that helps industrial plants manage their energy use, and we anticipate very positive results on that. But I think it's important that California gets this right. I've been involved with discussions about implementing the Clean Power Plan, and other states really look to California as a model. So we need to provide them with a good model. The rest of the world is watching, and the planet's future is depending on this. Thank you.
All right. I'd like to make a statement here. First of all, there are two very important conclusions here that I think we really have to pay attention to. One of them is with 15,000 people, only about 15% were willing to take up the measures. And so if we're going to retrofit our buildings, we do have to say, whether it's the liberal way or the conservative way, we really have to think very carefully about this. How are we going to do it? Upper income folks have fewer things. They may be working one job instead of two. They have other resources. Lower income, we're going to have to work harder. Another very important part of this is that the engineering estimates are not correct. Virtually all the studies I have seen use engineering estimates. And for the utilities, this makes a lot of sense because they can say that they've had a great success. And I've actually seen studies where they have the real data and the engineering estimate, and they throw out the real data because, the engineering estimate must be better. I'm sorry, real data is better. The third thing that was said by Professor Wolfram was that it's not cost effective. Now, there's a number of ways to look at that. One of them is that the price of gas is very low now, and that's going to change over time. And the other is cost effective. There's cost effective in terms of current costs. There's also cost effectiveness in terms of avoiding our coastal cities going underwater 100 years from now. My own feeling is that the price of carbon that we're using is appropriate to perhaps make changes in the utility industry, but it doesn't really look at what the full costs would be if we lose at most of our coastal cities. So we can argue, A, that the price of energy is low, and that's why, and that's going to change, and that's one concern. And the other thing we can talk about is the price of carbon is way undervalued. So, but I think in saying those things, we don't want to lose track of the first two, which is, A, it's hard to get people in low-income areas to take advantage of the programs, and B, we really need to improve our engineering so that we will be comparing against real data so we'll know what is the most cost-effective thing to do. And maybe the most cost-effective thing is, changing all of our utilities to renewables and not worrying too much about the buildings, because maybe there isn't a lot we can do. maybe there are certain things that we do that are extremely cost effective and others that are not. And I believe we'll hear from Ms. Piet, Dr. Piet, in the next section on this. So I'm just going to make those comments. Do other folks have questions? Yes, Assembly Member Jay Obernolte.
Thank you, Mr. Chair. So to say that the ex-ante model was incorrect, I mean, as being charitable, it wasn't even close.
Yeah.
I mean, we didn't even save half the energy that we were forecasted to save. So you said that more study was necessary to determine why, but I'm guessing that you probably have some initial conclusions as to why. Can you share those?
Yeah, so one thing we did rule out is the rebound effect. That's an explanation that's offered, but the last slide that I showed you ruled that out. I think they're just making overly optimistic estimates about how much energy we'll save. And one hypothesis I've heard is that the engineering model models the building but doesn't model what's in it. And what's in it might be carpets and drapes. So, for instance, if you have an inefficient window, but you have drapes over that window, then improving the window isn't going to save as much energy as the model that ignores the fact that you have the drapes there estimates.
No. All right, thank you.
All right, Assembly Member Williams.
I think that this is important research because I do think it should guide what kind of energy efficiency programs we invest in. I do think it's important to note that the engineer estimates predict such a overwhelming cost savings compared to other ways of carbon reduction that even 39% of the engineers' estimates, it makes it more efficient generally than other forms of carbon reduction, meaning energy efficiency still, would be a superior method to other ways like renewables or nuclear or other things. To me, though, this is important, though, saying, well, maybe going consumer by consumer is not the most efficient way to do this. Maybe going to multifamily homes that are not owned by each individual or more commercial or more industrial is going to be more efficient because you're not having to convince 9,000 people. You're having to convince fewer to make rational choices.
I know you're going to have a comment, Dr. Wolfram.
Is that okay?
Yes.
So for one thing, a response to something that Assemblymember Quirk said, yes, gas prices now are low, but in calculating the $2,500 in savings, we didn't use Henry Hub prices. We didn't use the wholesale price of gas. We used retail prices. And so the retail prices for gas build in a lot of fixed costs, and so are actually probably higher by a factor of 2 than the expected wholesale price of gas. So I think that the savings to society from reducing the gas use at a particular home are even lower than the $2,500.
Yeah, but you're talking about savings to society as the wholesale and then the retail. Go ahead, finish.
But the savings to society should include the carbon reductions. That's definitely true, and that's something that Assemblymember Williams brought up. We calculated that the dollar per ton equivalent, if you thought about the carbon reduction in this program, the cost of that was about $100 a ton. And so it's not outrageous, but it's not negative. So, for instance, the McKinsey curve that's waved around by a lot of people suggests negative energy efficiency, right. and that's not what we're finding.
With
Okay.
residential.
Yeah,
Right.
yep.
Now, the other thing is the one study that I've seen of California shows similar results with about a third of the gas savings that were projected by the engineering study at being achieved, and as little as 10% of the electrical. So we really need to look at this very closely so that we can go on with the same programs, but we have to know what we're doing. Maybe you can argue that you can make other arguments, like we're underestimating the cost of carbon, but we still want to look at the most efficient ways. And should we be spending it on buildings? Should we be spending it on developing renewable natural gas? You know, we have to know what we're doing. That's the bottom line. So, Dr. Piet?